Okay. Last class we considered FFT, and remember we are getting, original vector data vector was x0, x1, x2 up to x7, but this same data vector got thoroughly shuffled, Okay. Now, it is x0, x4, x2, x6, x1, x5, x3, x7. So, it is a new order. Originally, it was x0, x1, x2 up to x7. Now, it is x0, x4, x2, x6 dot as I told. So, for a big FFT, say 512 point and all that, you cannot go back and find out the order, right. But this order in which these elements have to be, elements of the original vector have to be, shuffled, okay, that can be obtained easily from some observation. Let suppose n is, as I told you, some power of r, like say n suppose is 16, that is 2 to the power 4. So, I will have small n equal to 0, 1 dot n minus 1, that is 2 to the power r minus 1. In this case, small n equal to 0, 1 dot up to 15. Okay. So, I have originally x n sequence, up to n minus 1. So, x of 0, x of 1, x of 2, x of 3 dot. Okay. Now, you remember what I did? I took the even point sequence, that is I formed a sequence like x 0, I put an underline to indicate this is the position of the origin, then x 2, x. Anyway, it is not required because it is a FIR sequence, I am starting from x 0 only. So, x 0, x 2, x 4 dot. Okay. And it will go up to, because n is even, so n minus 1 is odd, so n minus 2, that is the largest even number. So, it will go up to x. So, in this case n minus 2 in general. There is one sequence, I called it HR. So, HR, and other one I took GR, which was x 1, x 3 dot this order, last order element. Okay. HR is x 2 r, there is h 0, this is the 0th guy, h 0, this is h 1, this is h 2 dot. Okay. And how many I have got? N by 2 elements here. So, this is 0th, first, second up to n by 2 minus 1, again 0th, first, second up to n by 2 minus 1. So, rth guy HR is original x 2 r, and GR is original x, not just 2 r, but 2 r plus 1. Like if r is 0, it is x 1, G 0 is x 1, G 1 is x 3 dot. Alright, this is the situation. And then I wanted to find the n by 2 point DFT of this, n by 2 point DFT of this, and then the total DFT was obtained in terms of them. I got a butterfly diagram. Then again the DFT of HR, we to compute that this particular sequence we considered, again divided it into its own even part and odd part, similarly here, and did the same thing and went recursively backward, and the entire structure was developed. That we have done. Now, what are these indices in terms of r? This is 0, 1, 2 dot n by 2 minus 1 in terms of r. Same here, 0, 1. Now, so at 0th x 0 comes, at first x 2 comes, at 2 x 4 comes, at r x 2 r comes. Okay, dot. Now, you see these indices 0, 1 to 2 to the power r minus 1, like 0, 1 up to 15. All these numbers can be represented by how many bits? 4 bits, like r bits here. So, suppose I am taking the example of this. So, 4 bits. So, 4 bits are say maybe B3, B2, B1, B0. So, 0, 0, 0, 0, that is 0, 0, 0, 0, 1, that is 1, index 1, 0, 0, 1, 0, that is index 2, up to 1, 1, 1, 1, that is index 15. All right. Now, you see this is equal to B3 into 2 to the power 3. I am doing for this case, but you can easily generalize to the general case. 2 to the power 2 if I take out this part, this is divisible by 2. Okay. B 3 2 to the power 2, B 2 2 to the power 1, B 1 plus B 0. All right. If B 0 equal to 0, then this whole sum is divisible by 2, because there is 2 into this. So, that means even. If I call this n, n is even if it is in the 4-bit binary representation B 0 is 0. Okay. N is even means n is equal to 2 r, and that means this is r. All right. So, what I will do to get these elements x 0, x 2, x 4, I will take the index n, write it in the binary form, and I will pick up only those cases where B 0 is 0, because as long as B 0 is 0, I get even. And then this part, this is your r. See, B 0 is 0, total value is n, okay. And n will be 2 r, because it is even. So, this is r. This r will take 3 bits, B 1 plus B 2 to the power 1 plus B 3 to the power 2. So, 3 bits is binary representation, right. So, it will take 8 possibilities, and that is true, because r will take 8 possibilities 0, 1, 2 up to 7, total is 16, 8 here, 8 there. Okay. So, what I do, I have a tree like this, B 0 equal to 0 upstairs, B 0 equal to 1 downstairs. B 0 equal to 0 means I will consider 0 0 0 0, then 0 0 not 1, 0 0 1 0, because this I want to hold permanently at 0, then 0 1 0 0, then 0 1 1 0, okay. Then 1 0 0 0, then 1 0 1 0, 1 1 0 0, 1 1 1 0, all right, 1 2 3 4 5 6 7 8. So, this was actually n equal to 0, n equal to 2, n equal to 4 dot dot. So, I get all those even indices. So, I first what I do, I take B 0, I 0, B 0 equal to 0 case. So, B 0 equal to 0 case, only this 8 fellows come, and then I order them, I write them in this order here upstairs, these fellows, and downstairs if B 0 is 1, if B 0 is 1, n is odd, it is 2 r plus 1. So, again this is r, 2 r plus 1. So, this is r, okay, and r will take total 8 values. When B 3, B 2, B 1 are 0, it will be 0. When 0 0 1, it will be 1. When it is 0 1 0, it will be 2, like that, because you see 2 to the power 2 to the power 1, like that. All right. But here I will write them in this way, 0 0 0 1 I will hold, this will correspond to n equal to 0, okay, because 2 r plus 1. Well, this corresponds to no, this corresponds to n equal to 1, r equal to 0. All right, n equal to 1, 0 0 0 1, okay. Then 0 0 1 1, n equal to 3, then 0 1 0 1, n equal to 5 dot 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 up to 1 1 1 1, okay, n equal to 15. Here last bit is 1, that is why it is odd. So, the B 0 is 1, remaining part B 2, B 1, B 2, B 3, if you take the 2 out. So, these 3 digits, like these 3 digits here, they will take 8 values, and in ascending order 0, 1, 2, 3, like that. So, I hold them, okay. After I see, here I took B 0 equal to 0, and then I put this array under B equal to 0, this array upstairs. Here I am not writing it, but suppose I write all these values, 3 values under B 0 equal to 0 case, all these 3 values here, all these 3 bits, okay, 0 0 0 0 0, and all of them are pushed upstairs, 0 0 0 0 0 1 0 1 0, that is these 3. Similarly, when B 1 equal B 0 equal to 1, okay, I have got 2 r plus 1, that is n is odd, Okay, it is 2r plus 1. So, again r will take these 3 bits only, the decimal value, because 2r plus 1. So, under b 0 equal to 1 case, again I write the same order 0 0 0 0 0 1 0 1 0 dot on this side, but under b 0 equal to 1 case. Now, what I do, I am just considering these 3. So, this will be r equal to 0, r equal to 1, r equal to 2, r equal to 3 dot dot dot. So, it is now 8 point sequence. In my next stage, as I told you, I will consider the even point component of this indices. So, 0, okay, this is the r equal to 0 case, that is why this fellow is 0, then equal to r equal to 2 case, that is why again this fellow is 0, because now I am considering 3 bits only. Under b 0 equal to 0, okay, I got the even point fellow. So, this is my r equal to 0, r equal to 1, r equal to 2, like that. R I am now considering its own even points are this guy 0 0 0, then next is 0 1 0, then next is 1 0 0, then next is 1 1 0. Okay. So, wherever I have got 0 at the LSB, I hold it. But what is that bit? That is B 1. So, here again I go up B 1 equal to 0 case, and here B 1 equal to 1 case. Under B 1 equal to 0, under B 1 equal to 0, I have got this guy 0 0, then 0 1, okay, just 2 bits 0 0 0 1, 1 0 1 1, okay, 2 bits. This will be new r equal to 0, r equal to 1, r equal to 2, r equal to 3. So, these 4 are pushed up, these 4 cases with B 1 0, B 0, B 0 0. So, B 0 0, then B 1 0 and remaining 2 bits 0 0 0 1, 1 0 1 1, they are pushed up. And similarly, I take the odd case. So, this one, this one, this one, this one, which have 1 at the LSB. So, then again r will be this much 0 0 0 1, 1 0 1 1, same thing. Okay. R will take those 4 values under B 1 equal to 1 case. So, under B 1 equal to 1 case, those 4 will come on downstairs. Similarly, here under B 0 equal to 1 case also, if B 0 is 1, but I still have this array only here, because B 1 is 1, this is 1, but this is same as this. So, here 0 0 0 0 0 1 0 1 0 up to 1 1 1, that is r equal to 0, r equal to 1, r equal to 2 up to r equal to 7. They were here. So, those are those indices. Again I divide them into even point and odd point. How? I look at this guy, this is the LSB now. Whenever that is 0, I move up. That is under B 0 1, B 1 0, and whenever that is 1, I move below. So, here again I give 4 indices, that is 0 0, 0 1, 1 0, 1 1, and here also by the same way it will be same. Then I have got 4 point sequences. Okay. This again I break up into 2 parts. 4 point sequence means 0 0 0 1 1 0 1 1, that is 0, r equal to 0, r equal to 1, r equal to 2, r equal to 3. So, these and these, they are the even points. This I push up. So, for them this fellow is 0, this fellow is now B 2. So, I go up. So, under B 2 equal to 0, I have got 0 and 1, just 2 values 0 and 1. Okay. 0 and 1, 1 is 0, 1 1. So, r equal to 0, r equal to 1. This is my even point, this is odd point. So, now here I go for B 3 equal to 0, B 3 equal, because this is last bit, this is B 3, B 3. So, B 3 0, B 3 0, B 3 1, B 3 0, B 3 1. You can easily understand that when B 2 is 1, even then I will have the same thing, but by the same logic. So, under B 2 1, again I will have B 3 0 up, B 3 1 down. I am not completing this tree, there is no space. Again B 2 equal to 0, B 2 equal to 1. Dot dot dot. Okay, I am not completing it. So, again it is B 3 0, B3 1 dot dot dot. So, who comes on the top of the scale 0 0 0 0? Okay. But what is that number actually? Because that number for that in terms of n, B3 was the MSB, B0 was the LSB. So, B3 0, B3, so actually who comes on the top? B3, you can write this way, B1, B0. So, 0 0 0 0, 0 0 0 0, this guy comes on the top. Okay. B3 0, B2 0, B1 0, B0 0. Then who comes? B3 1, okay. B3 1, then 0, then 0, then 0. So, this way. Okay. So, you see, if it is a scale, who comes first? 0 0 0 0, then 0 0 0 1. So, 0 0 0 0 in a scale, for the time being forget this, let me write this way, B0 this way, B0 in this reversed order, B0, B1, B2, B3. Okay. So, who goes on the top? 0 0 0 0. Okay. But that is actually in terms of n is what? B3 0, B2 0, B1 0, B. So, this guy. So, 0. Then next guy is 0 0 0 1. Okay. 0 0 0 0, then 0 0 0, next guy in the scale. So, next guy in the scale is 0 0 0 1, but what will be the value of small n? We have to start from B3. So, 1 0 0 0, 1 0 0 0, because actual number was n, that was B3, B2, B1, B0. Okay. All right. So, this will be 1 0 0 0, so 8. So, this will be x 0, x 8. Next index is 0 0 0 1 done, then 0 0 1 0. Next in the scale, this is the scale, this guy, this guy, this guy, 0th guy, first guy, second guy. So, 0th guy, first guy, second guy, third guy, like that. 0th guy means 0 0 0 0. Then I go like this. So, I get these values B0 0, B1 0, B2 0, B3 0, that is pointing at the top. And but who will be that value? For that I have to start with B3 first in the MSB, then B2, then B1, then B0, because that is how number n was. N was B3, B2, B1, B0, and that is 0. Then I have 0 0 0 1, that is the next guy in the scale. This was first guy done, now next guy 0 0 0 1, 0 0 0 1. But in terms of original n, it will be 1 0 0, so 8, 1 0 0 0, so 8, x 8. Then again 0 0 1 0, that is 0 0 1 0. Okay, that is number 2. But that will be actually 0 1, this is B3 0, 0 1 0 0. Okay, that is 4. Then again 0 0 1 1, 0 0 1 1. Okay, there is the next guy, number 3. This is 0th, first, second, third in this scale. So, now the third guy is 0 0 1 1, that is why pointing here, this is pointing there, this is pointing there. This. But third guy means in terms of n, B3 is the MSB. So, 1 1 0 0, 1 1 0 0, that is equal to what? 12. Okay, and dot 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 dot, and you get that order, okay, in which these guys will be finally arranged on the scale. We started dividing into even part, odd part, then again further even part, odd part, then further even part, odd part, then it became 1 point sequences, even part, odd part, and 1 point sequences. So, even odd, again even odd, again, okay, and that is the order. Okay. So, in this order 0th position is 0 0 0 0, here you get B3 0, B2 0, B1 0, so 0. Then 0 0 0 1 means actually 1 0 0, there is x 8 dot 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 dot. All right, this is called bit reversal order. Okay. I do not know whether I have time enough to do this. I will leave it as an exercise to you. Suppose they have got a filter. If I have filter 0 to n minus 1, and you got a h n, you got a sequence infinite long or very long sequence. This is your x 0, x 1 dot 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 dot. You want to convolve them. Then one way to convolve is that this sequence, suppose you break into some 0 to L minus 1, then next one is L to, so this is one block, the next is another block, L to L minus 1, then another block, and then convolution is a linear operation. So, this sequence is summation of this sequence plus this plus this plus this dot dot dot. So, convolution of h n with the overall means convolution with h n with this plus h n with this plus h n with this, convolution of h n with anybody, say with this. Okay. That you can do by convolving this with, you can bring this entire stuff here, all those samples here first, convolve between h n and that block, and then you can shift it by this much amount. Why? Because in terms of Z transform, convolution means the product of the two Z transform, H Z and Z transform of that block. But that block means Z to the power minus, if it is 2L, Z to the power minus 2L into the Z transform of this block when put here. Okay. So, first you convolve between H Z and this Z transform of this block here, multiply, and then Z to the power minus 12 means result has to be shifted here. Okay. So, if you convolve between say this and this, you know, by convolution it will stretch. Like if you do graphical convolution, this will be reversed. If you are doing with only this block, suppose you are dealing with only this block, and the other one, this is reversed, and if you keep shifting it, you know, it will finally, I mean, if you reversed H 0, H 1, H 2, that is the way, na? H 0, H 1, H 2. So, you get a output at 0. If you shift it to the left, nothing. If you go shifting to the right, when H 0 will come somewhere here, last guy will still be here. So, you will get over a longer range. So, this output you save. Okay. Then again, so the output is stored. Then for convolution between this and this, what to do? You bring this block as I told you here and convolve this with this. So, you get an output, that output you shift by L, because if you call this to be say something, say x prime n, this block is nothing but delayed version of x prime n, delay by L. Okay, so, better you, that means Z transform of this block alone would have been Z to the power minus L into Z transform of this x prime n, say capital X prime Z, that into H Z. So, first carry out H Z into x prime Z, okay, which is nothing but convolution between these two, and then apply Z to the power minus L, that means shift the result by L. So, you convolve this with this and shift. So, that result again will start after shifting, will start from here and will go like this. When you add, this part will be added. Again, next block, and this is expanded, right? You start from L, but does not remain for a length of L only. It becomes actually L plus n minus 1 total length. So, again it will enter the next block. Then again you take convolution between these two. First you shift it here, convolve the two, and then shift the result here. So, again there will be things like this. This is called overlap and save method. You can use DFT to do these convolutions. As you know, you have to do zero padding, so that the length of the two sequences is same. So, this block if length capital L and this is n, you have to add some L plus n minus 1 or 2, I have forgotten that many zeros here, and so total length will be L plus n minus 1. Okay, it is n. So, L minus 1 zeros here, n minus 1 zeros here to this block. So, total length will be L plus n minus 1, that many point DFT, DFT into DFT, inverse DFT, you will get this result. Similarly, this result. This is one way called overlap and add. There is another one which is called overlap and save. Now, I do not have time because it will take little longer. So, I would leave it as an exercise to you to read from the book. Okay, that is not very difficult. So, I conclude this course, and I hope by this journey through this course, you could get some useful material in this topic. Thank you very much.